Welcome to lesson 3.4, titled The Chain Rule. And as you may guess by seeing the word rule in the title of this lesson, we are going to learn another major differentiation tool to join with our power rule and our product and quotient rule. And what we're looking at is a problem like what you see here. F of x equals the quantity 3x to the fourth power minus 2x plus 5, all raised to the third power. And this is an example of a review concept, composite function. We have one function acting as input to a second function. In this case, we're taking the function 3x to the fourth minus 2x plus 5 and raising it to the third power. In this one problem, we have two different functions that we're trying to differentiate, but they're not arranged as a product or a quotient or as a sum or difference. So this lesson focuses on differentiating any functions that are written as composite functions, following what's known as the chain rule. And what the chain rule states is that in order to differentiate a function of the form f of g of x, where this other function of x is the input to our f function, we have this inside rule and an outside rule. How we differentiate that is we take the derivative of our f function, leaving the inside that g of x function alone, so f prime of g of x, times the derivative of the inside function, times g prime. And so one way to try to remember that is derivative of the outside times derivative of the inside. And the biggest part of this lesson in using this chain rule is to identify anything that's written as a composite. So let's go back over to our example. In this f of x function, we have 3x to the fourth minus 2x plus 5 all being raised to the third power. We have an inside function with this outside rule telling us to raise that function to the third power. And so what the chain rule states is that in order to do this derivative, we are going to take the derivative of the outside first. So focus on this function. The derivative of something to the third power, we know from power rule, is 3 times that something raised to the second power. And we can just go ahead and keep calling that the inside. And chain rule also states that we are then going to multiply by derivative of that inside function. So derivative of this. And derivative of 3x to the fourth is 12x cubed, minus derivative of 2x, which is 2. Derivative of 5 is 0. It goes away. And how we finish this up is I don't want to write inside. And as you get used to this, you're not going to worry about that. I also want to find spots where I can simplify this problem. Well, I can multiply 3 times this other function that's not being raised to a power, the one that I don't need to expand, and get 36x to the third minus 6 times, now I said inside squared, but I'm not going to write inside. I'm going to change that back to the inside function. And there is my derivative of my f of x function, applying the chain rule. Let's try these two functions here. Notice we have f of x equals square root of 4x minus 3. And one thing I like is make sure that you're good at reading all these problems out, because if you are, when you say the word square root of 4x minus 3, saying that of is usually a good sign you're dealing with a composite function, this outside function of the inside function. Now, if you need to be able to keep track of things, keep writing what your functions are. I'm going to write that my outside function equals square root of the inside, or equals inside to the 1/2, and the inside function is 4x minus 3. So applying the chain rule, f prime of x will be derivative of the outside function, 1/2 inside to the negative 1/2, times the derivative of the inside, derivative of 4x minus 3 is 4, and putting it all together, f prime of x will equal, well, 1/2 times 4 is 2. We're going to go with our inside function. We're going to rewrite it as the actual function, raised to the negative 1/2 power. And if you want to, you can get fancy with these and turn them back into different notation. Big thing is I want to get us to this point. Get to there and you are good to go. So let's look at the problem on the right then. Y equals 2x to the third power times the square root of 2x to the fourth minus 9. Well, we have two issues here. The first thing was I said that we were doing 2x to the third times, and then I'm doing square root of 2x to the fourth minus 9. I've got a composite function down here, but I've also got a product of two different functions. We are going to have to apply the product rule and that new chain rule. But the big thing is to treat this just like we did the original product rule. If you had just seen 2x to the third times square root of x, we would have known what to do with that. It's no different now that that square root has something more complicated inside. So in order to get dy dx, we're going to take For product rule, we're going to take derivative of the first, which is 6x squared times the second left alone, plus the first times, and here's where we're going to have to be able to differentiate that square root of 2x to the fourth minus 9. And realize that the outside equals 2x to the fourth minus 9 all to the 1/2, and the inside equals 2x to the fourth minus 9. So we're going to take the derivative of the outside first. Get 1/2, 2x to the fourth minus 9 to the negative 1/2, and then times derivative of the inside function, which is 8x to the third. And don't even worry too much about simplifying that. I'm going to show you, there's one little thing you can do for that. There's a little extra, but I'm not worried about that right now. An evaluation problem. F of x equals 1 over square root of 3x minus 5. We can rewrite that as 3x minus 5 to the negative 1/2. Notice we have outside, which is that inside function to the negative 1/2 power, and we have an inside of 3x minus 5. And so to find f prime of 7, we're going to first find f prime of x. The derivative of the outside is going to be negative 1/2. The inside function, which is 3x minus 5, subtracting 1 from that will give us negative 3/2, times derivative of the inside function, 3. Putting that together, we'll have negative 3/2, 3x minus 5 to the negative 3/2, and we want to evaluate that at 7. And we'll go ahead and confirm that on the calculator and get this weird looking decimal, negative 0.023. And I would also suggest we confirm that using our Math 8 using our derivative tool. And you can see we get the same answer. Next up, find the derivative of f of x equals square root of 3x plus 1 all over 2x plus 1. This is like the example we saw a couple problems ago, except now I've got overall something that is a quotient rule problem, but still notice when I get to the square root of 3x plus 1, the outside function on that is this inside part to the 1/2, and the inside is 3x plus 1. But overall, this is one giant quotient, so we're going to use the quotient rule. F prime of x will equal my low function, my 2x plus 1, times the derivative of the top function. So we're going to have to do that right away with the chain rule. Derivative of the outside will be 1/2, keep that 3x plus 1 to the negative 1/2, times the derivative of the inside function, 3, minus the top function left alone, times the derivative of the bottom function, 2, all over the denominator squared. Now, if you want a challenge, that is what this function will look like put into a simpler form. Me, again, I'm worried about, can you get to this point? Can you notice that first step was applying the quotient rule, and second step was applying the chain rule on that square root of 3x plus 1 function? If you could notice that and understand how we reach this step, then you're in good shape. And let's look at the one below it, because this looks like a big jumbled mess, but let's see if we can make some sense of it. And you have a couple routes. One would be to think of this entire quotient as a big inside function being raised to the third power. Your other option, I know taking the quotient to the third power, I can rewrite this as the numerator raised to the third power and raising the denominator to the third power. It's already got an exponent of 2, so 2 times 3 will give me the 6th power. There's nothing I can do to simplify beyond that point, but now what I can see is I have overall a giant quotient, and I have the chain rule on the top and bottom, the numerator and the denominator. Let's go ahead, right into our derivative. F prime of x will equal the bottom function left alone times the derivative of the top function. Outside is equal to the inside raised to the third power, and the inside function is t squared plus 1. So we're going to have derivative of the outside, which will be 3t squared plus 1 to the second power, times derivative of the inside, derivative of t squared plus 1 is 2t, minus the top function left alone, times the derivative of the bottom function, and this is its own separate chain rule. We've got an outside, which is the inside raised to the 6th power, and we have an inside function that is 3t minus 1. So its derivative would be 6 times that inside function raised to the 5th power times derivative of that inside function, which is just 3, all over the bottom function squared, which would make that to the 12th power. And again, if you want to go for an answer that is most simplified and completely factored in the numerator, this is what you could end up with. But to reiterate, I'm not terribly worried. If you can get to here, we are in very, very good shape. And let's finish up with a familiar looking set of problems down at the bottom. We want to find f prime of 4 given the following function values for g and g prime, and for h and h prime all evaluated at 4, and utilizing these three different f of x functions. The first one has f of x equal to the quantity g of x squared. Notice we have some function being raised to the second power, and that function is g of x. F prime of x will equal the derivative of the outside, which is 2 times the inside function raised to the first power, times the derivative of the inside function. And evaluating that at 4, we'll get 2 times g of 4, which is 3, times g prime of 4, which is negative 2, and f prime of 4 equals negative 12. Moving on to the second problem, f of x equals square root of h of x. Again, that square root of lets us know we are dealing with an outside that is a square root, or a 1/2 power for the inside function, and the inside in this case is h of x. F prime of x equals derivative of the outside, or 1/2 h of x to the negative 1/2 times the derivative of the inside, h prime of x. The only other thing I'll do on this one is make sure that we can get back to something that's going to be easier to evaluate. That's going to be 1 over 2 square root of h of x times h prime of x, and f prime of 4 will be 1 over 2 times the square root of h of x, and h of 4 is 9, times h prime of 4, which is 5, and f prime of 4 will have a 1/6 here times 5 will be 5 over 6. And finishing up, we'll define our last f of x function as h of g of x. Again, I said of, so I know I'm dealing with an outside-inside situation. The outside function here is h of the inside function, and the inside function is g of x. So f prime of x will be derivative of the outside, h prime of the inside left alone, times the derivative of the inside, g prime of x. So we'll get f prime of 4 equals, now this is going to be h prime of g of 4, and g of 4 is 3, times g prime of 4, which is negative 2. Now we were not given anything to tell us what h prime of 3 is, so we're going to have to leave our final answer as negative 2 times whatever h prime of 3 would end up equaling. And that completes your lesson on the chain rule. And this lesson is going to become very important because what we're going to be able to start adding on are more types of functions that are generally written as composite functions. And specifically, this is going to lead us into conversations about how to deal with trigonometric functions, which you will see in the last lesson of this unit. Please make sure that you review and summarize your notes and ask any questions that you may have. Thank you for watching.